Welcome to the Value of Testing podcast. My name is Randy Rice. I am your host, and today I'm going to present 5 commonly used metrics in testing that can be very misleading and even meaningless. Now, some of these may actually shock you because you may be reporting some, if not all, of these metrics right now in your dashboards and your test reports. And I also want you to be sure to hang with me for this podcast because at the end or toward the end of the podcast, I'm also going to be presenting some of my top most meaningful metrics. And this is especially important in a time when AI is driving how we build and test software and even how we report on what we're seeing in the results of our test. Now, I believe that testing should be a measurable activity. Really, in fact, if you think about it, testing is measurement. You are creating ways to know the extent of things, the level of quality of things. But that's true only if the measurements and the metrics really mean something. And even more so if there's a common shared understanding about what each of these metrics really means. Now, I used to think that when I was trying to decide on which metrics I would capture and report, perhaps putting them on a dashboard or something, I would go out and I would seek stakeholder input, and that carried a lot of weight. Well, what I learned was that what people want is not necessarily what they really need. And so yes, I do believe that we need to have a conversation with our stakeholders to really understand maybe what their true interests are, but they may not understand totally the metrics well enough to really make an informed decision out of those metrics. Now, ultimately, most people, they just want to know if something is ready to release and what the risks are around that release. And, sometimes actually the release is a given. Okay, the release is going to happen. The big question is how bad or good will it be? So with that said, let's get into them. The first metric I want to talk about as being rather meaningless is a big one. It's test coverage. And I know you probably think about this if you're a tester and reporting on things out of testing, things like the percentage of user stories or requirements, for example, that have been covered by test, maybe the percentage of test cases performed, the percentage of statements or branches tested in the code. But the problem is here that just because you've achieved even full 100% coverage of something doesn't mean that you've covered it in depth. For example, I could say that I've achieved a 100% requirement coverage level by performing just one test per requirement. But that wouldn't really be very meaningful, would it? In fact, it could give me a false sense of completion and confidence. I could say I've tested 100% of the test cases, but what do those test cases actually verify or validate? I could just have a few even. It doesn't really speak to the extent of the test cases, which tests might be missing. Now, by the way, in this age of AI, this is a really great opportunity for human analysis and critical thinking, to be looking at really what your test cases mean. And I'm a big believer in test cases, but I'm also a big believer in having meaningful test cases and the right test cases. Another example here is that maybe a developer might say that they've tested every line of code. Well, that's great, but it doesn't tell me if every decision has been tested or every path has been tested. And even if those paths and decisions were tested at 100%, I'm relying on the code as the basis of the test. And the only way to know if that code is correct is to look at the specifications for what the code is really supposed to do. Where do I learn that? Well, we have to go to the user stories or the requirements or some other external source to get that. Now, here's something to think about, though. What if I report that I've tested 90% of something? Well, that kind of leads some troublesome thoughts, I guess, or leads to some troublesome thoughts like, well, what about that other 10%? Is that important? Is it meaningful? And in fact, does that 10% gap there, does that tell me anything? Maybe we've made a choice to omit those tests, and maybe they were low risk. On the other hand, they could be important things that got blocked. So it's not just this coverage percentage that we need to be looking at. There's actually a much deeper story behind the coverage. Now, if you can find a way to make that meaningful, make the message around that, then go for that. But if you're just having a little widget on your dashboard to get to green when you've reached 100% of something, I would suggest that that's a pretty meaningless metric. The second metric would be the percentage of tests passed and failed. I want to tell you a quick little story. One time I was on a contract, and one of my tasks on that contract was to develop a dashboard for the client. And so I put together the dashboard. I kind of went out and learned what they were interested in and that kind of thing. And so one of the metrics on the dashboard had to do with the percentage of tests passed and failed. And I think maybe the percentage that I shown was around maybe 85%. Well, when I did the demo of the dashboard, some people felt like 85% was fairly good for them. Hey, 85% of our tests are passing. Yay! Normally it's only 50%. That kind of thing was going on. But then there were other people in the group that said, well, wait a minute, shouldn't we have a higher percentage of tests passed? Shouldn't it be like almost 100% of the tests passed? Well, where the gap of meaning there was that was just the current state of the pass-fail. That was not the eventual pass-fail that we would hope to see before release. That percentage of passing ideally would continue to increase and increase until you get up to a very high percentage of your tests passing. But let's say that we do report that 80% test pass rate. Is that good or bad? Is it the final pass rate? And then what about the 20% there that didn't pass, that failed? Were those important test outcomes to know about? And would any of those failures indicate maybe some kind of high-risk problem that might delay deployment? Now, one other thing about this metric is that it really contributes to this thing where we go for green, as my friend Greg Pascal calls it. Is kind of a trap where people they only care about getting everything passing. They don't really care for things that may be problematic, maybe not revealed by the test. They're just concerned with having a dashboard that shows everything nice and green. And that can be very, very misleading. And a lot of that goes to the percentage or to the number of tests even that have just passed and failed. Okay, the third metric is the percentage of defects fixed. Now, once again, yes, you would think we really need to know about that, right? Let's say that I report 99% of the defects that have been found have been fixed. Well, that looks good, doesn't it? Well, what about the 1% that weren't fixed? Are those serious? Would any of those defects indicate a high-risk problem that might delay deployment? And plus, what if it's very early in the project and we maybe have only found a few of the very many defects that are yet to be found? Just because I'm saying a certain percentage have been fixed, that really doesn't tell me a whole lot about really the overall quality. What were the levels of severity of those defects, for example? Now, I'm going to kind of discuss this maybe in a little bit different context when I talk about the meaningful metrics here toward the end of the session. But the fourth metric is one that I really take a lot of care with, and it's the velocity of testing. It's the speed metric. And the assumption behind this is that faster testing is better. But it doesn't always account for the quality of the testing. In fact, it hardly ever accounts for the quality of testing. I mean, I can make testing go really fast by simply running fewer tests. So the key here is not the speed of testing, but it's what we're learning out of the testing that we do. Now, yes, we also need to make good progress and good time and not to become known as the bottleneck of everything. But we also need to take the time to get meaningful information out of testing. And sometimes that just takes time. Sometimes we get tests that are blocked and things that are happening. What about the major showstopper defect? And we can't go any further until that one gets resolved. Now, of course, many people that are outside of the testing group want it to go faster. And typically, they will see automation as the way to make that happen, and also to show great results and not to introduce delays and those kind of things. But in the real world, tests fail. Automated tests will break, and defects take time to fix and retest. In fact, I would say that probably one thing that people underestimate the most that I've seen is the number of secondary cycles of testing that need to be performed. The fifth metric, and the final one of my misleading metrics here, the meaningless metrics, as I'm calling them, is the percentage of tests automated. Now, a lot of people seem to be interested in this one, and many times they will put 100% as the goal of tests they want to have automated. But really, we have to ask, do we really want all tests to be automated? Is that even reasonable? What about those tests that require manual intervention or some kind of manual assessment of what's going on? That will keep the numbers less than 100%. And at that point, then management may become dissatisfied over time because you're not reaching that holy grail number there of 100%. But there's also some other questions to ask around that and answer as well. For example, if we were to achieve 100% of all of our tests, assuming that those are meaningful tests, would we be able to maintain that level of test automation? For example, those scripts, once again, they will probably break when changes occur in the application. Are we able to keep up with that kind of maintenance? Once again, are we automating the right test? And it's not just a matter of just saying, okay, we're going to go in and we're going to automate a bunch of tests, because many times we have test cases that are in our library that may be redundant, they may be outdated. We really have to take a close look at that. So those are my top 5 of the meaningless metrics, and I would encourage you to look at what you capture and compare to that. Now, let's look at some metrics that I think are meaningful, and I'm going to give you the pros and cons of each one of these. I just have a handful here. But the first one is one known as defect detection percentage, or DDP. Now, this metric is really based solely in the number of defects that have been found pre and post release. And what you do is you express that as a percentage, and you take the number of defects that you're finding in all of your testing and divide it by the total number of defects found, either for the life of the release or for a certain time after the release. So like if we find 85 defects in our testing, all things that we use to test, unit testing, system testing, acceptance testing, all of that, and 100 defects have been found for the life of the release. Maybe after release 15 more were found. Our DDP would be 85%. Now, the 15%, those are the post-release defects. Those are the ones that either customers are finding or we're finding some way after the release. They're found by someone other than us. Now, the great thing about this metric is that it can tell you based on the defects, pre and post release, how you're doing in your test effectiveness. How good are your tests release by release? And you may kind of have a line graph that appears in kind of a zigzag, or you might find in one release your DDP is 70%, the next one it was 80%, in the next one it was 50%. And you can tell from that your effectiveness is all over the place. It's not very predictable at all. And you need to take a close look at some other things going on there. You may need to improve your test. You may need to improve your development processes. Now, the downside of this metric is purely historical. It doesn't help you with the project that you're on at a given time, or the release that you're in a given time. It's one of those look back kind of metrics, but it is a way that you can start to see trends over time of how you're doing. Now, there's also kind of a cousin of this metric called defect fixed percentage, or DFP, which not only indicates the number of defects found, but the number of defects found and fixed in the same way that DDP would report them. My second metric that I think is really important, really meaningful, would be risk levels. Now, you might not think of this immediately as a metric, but it is an assessment that gets made, and it can be made in many different ways. Sometimes it's just a single rating, like low, moderate, high, very high, those kind of things. And it can also be seen in various ways. For example, it could be a product risk that relates to the thing that you're testing. It could be business risk, and what risk are we exposing our business to if we release this application. It could be project risk, which really speaks to how we're building and testing the software that we're releasing. Do we have the staffing we need? Do we have the tooling that we need, etc.? And then there's also technical risk. Are there things that we need to be paying attention to there? This typically has to do with resources and performance and security and those kind of things. So how you express this, it can be rather nuanced, but this is one of the main things that decision makers are interested in, to know what you assess the level of risk as being. So the downside of this one, and I actually have a conference presentation called The Risk of Risk-Based Testing, and I think I came up with like 13 or so risk of risk-based testing. The most common thing that I always point to here is that most risk assessments are going to be subjective at some point. You may come up with numbers, you may come up with graphs, you may come up with all kind of really accurate looking outcomes from your risk assessment. But at some point in time, someone is having to look at something and say, okay, that's a low, moderate, high, that's a 1, that's a 5, that's a 10, or something like that. And think about this. Even professions that do this as a core of their work, things like banking and weather forecasting and insurance underwriting, they get it wrong sometimes. And they have all kinds of tools and things that are much more sophisticated than we have in the software field. I often sometimes say we as software testers and as software developers, we approach this more like a hobby than some kind of scientific method. Also consider one more thing here too, that risk is a potential. It's not a certainty. So there's always room in that for some degree of inaccuracy and failure of getting it right. Now, the third metric is mean time between failures. Now, if you're concerned about reliability and also sometimes when to know to stop testing, mean time between failures can be a way to know that. The good news here is that it can be measured fairly easily before production. However, you do have to take care that you're you're measuring timing along with the failures or the incidents that you're seeing. And that can be a little bit tricky to do sometimes. Sometimes automation is a way to do that. Now, the downside of this is that this metric can be manipulated by the speed of testing and also the scope of testing. So, for example, if I were to slow my testing down or my testing gets slowed down for some reason, the mean time between failures are naturally going to increase, which that looks like a good thing at first glance, but really is kind of a false reading there. Now, if I do reduce the test, then the mean time between failure may also increase because I'm testing less. That's another possibility there too. But the main takeaway here is that mean time between failures depends on a consistent testing effort. And many times about the best way to achieve that is through automation and to try to keep something under test. One other thing to note here on the mean time between failures is that you can measure that in production as well as during the development and testing cycles through monitoring or other kind of means like very timely user reporting of failures that are seen. Of course, sometimes that detracts from the accuracy of mean time between failures. A fourth metric is confidence level. This is a really important assessment metric that will many times result from other metrics. Now, essentially, we're trying to answer the question, how confident are you that the software is ready to release and will work well in production? You might base that on things like maybe defect levels, test results, especially acceptance test results, mean time between failure, and other things to kind of come up with an assessment of a level of confidence that you might have. Now, it is a fairly understood assessment, easily understood, that you can express this as we have maybe a low, moderate, or high level of confidence. But the bad news about this one is that it tends to be very subjective in nature, kind of like risk. It can also be based in risk as well as some of the others that I mentioned. Another metric, the fifth one, is the defect backlog. And in my opinion, this is one of the most important metrics we can track. Basically, what you're measuring is the number of open defects that the developers are still working on. Now, if that number continues to rise with little or no decrease, then basically the pile that the developers are working on is just getting bigger and bigger. And without some type of pause or refocusing of testing or something to let the developers catch up, then the pile gets so big that it never gets fully resolved. You wind up incurring a lot of technical debt as well as risk. And also keep in mind here that each defect fixed will also need to be retested and regression tested, which will lead into other cycles of testing. That's one of the fallacies of this whole thing. A lot of times you'll see this occur when people want to start testing really early, and the thing that you're testing is not ready to be tested, but you're generating all of this stuff, all these defect reports and stuff, and you know you're going to have to test it all over again. And even things that are fixed may even have to be refixed because maybe they're going to change at their core. The sixth metric is the cost of rework, and kind of an associated metric to that, the cost of quality. Now, the cost of rework will tell you how much time and money is being spent just on, or wasted, basically, I should say, on defect fixes. And the cost is not only to fix the defect, but also the cost of other impacts, such as maybe business loss, fines, lawsuits, those kind of things. And, you know, if you need to know how much money is going down the drain, basically, and time, once again, with your rework. But this other metric, the cost of quality, it will include the cost of rework. Now, if you talk about the cost of software quality, it's the cost of rework pre and post production release. But it also talks about the cost of testing and the cost of preventing defects. And all of that together is expressed as a percentage of the total cost of development. Now, ideally, you want to see the cost of quality decreasing and the overall quality levels increasing. One thing that you can do with this metric is that you can see, okay, here's where we're at today. Certain percentages at each of those levels of all the things that I just mentioned, the cost of testing, the cost of prevention, and the cost of rework. And just ask, well, if we were to increase the cost of prevention and maybe increase the cost of testing a little bit, we might dramatically reduce the cost of rework, and that might free up an extra, let's say, 10 to 15% in the cost of quality. And that is found money, basically. That is where the value is shown in your testing. Now, finally, my seventh and final one here would be defect categories. Now, this may not be a metric as such, but it's something that is really a good practice. One of the best things you can do if you want to start to improve the quality of something is to start what I call a bug collection. Once you know the types of defects that are being the most common that you experience, then you can start to focus on those. You can start to fix and prevent them through things like root cause analysis. And once you get one category under control and you've reduced it greatly, then you can work your way down to the next highest defect category and continue that process as you go down through the various categories of defects. So my conclusion here, and by the way, I didn't mention it before, but if you find this information helpful, please subscribe and share this podcast. I really do appreciate that. Just wanted to say that before I got out of here. But the thing I want to leave you with is that, metrics are great. Nothing wrong with metrics. You just have to understand that they can be manipulated. I always think of this Dilbert cartoon. And I would show it here, but I don't have copyright permission. But I'll describe it to you. Where in the first panel of the cartoon, the pointy-haired manager goes into the development team. And he says something to the effect of, as part of our quality improvement effort, I'm going to pay you guys $10 for every defect you find and fix in your own work. Panel 2, the Wally and Dilbert and all the rest of the developers are celebrating. And then in the third panel, Wally says, I'm going to code myself a minivan this afternoon. So, and then the manager walking away saying, I hope this drives the right behavior. Just understand that metrics can drive behavior. In fact, they will drive behavior. So, there's this old adage that you get what you measure. I kind of tack on to that, and that's not always a good thing. So think about these. If you have any questions or any other thoughts, I'd love to see these in the comments. You can always reach out to me from my website at riceconsulting.com and mysoftwaretesting.com. I encourage you to go and out there to see some of the other stuff I have going on. Also, just to engage with me, I'm out on LinkedIn quite a bit. So I would love to hear your thoughts on this topic. I think it's an important one. And hey, if you're going to be measuring stuff, you may as well be measuring the meaningful stuff. Well, that's it for now. I'll see you in the next episode. Thanks for watching.